operation on set 1, 2, 3, 4, 5 defined by A star B is minimum of A and B, write the operation table. Now first of all let me define this A star B. How is it defined? He says A star B is defined as minimum of AB. For example, what is 3 star 5? So what is minimum out of 3 and 5? So it is defined as minimum of 3 and 5, that is 3. So remember 3 star 5 will be how much? 3. So using this binary operation we have to make a table. So let me make a table. This is your minimum or the star operation, and the elements in the set are 1, 2, 3, 4, 5. So for making an operation table, what we do that in the extreme left column we write 1, 2, 3, 4, 5, and the top horizontal table also 1, 2, 3, 4, 5. And how this table will work? It is like this. 1 star 1, the result we shall write here. So what do you mean by 1, 1? The 1 star 1, what is minimum of 1 and 1? 1. What is minimum of 1 and 2? 1. So because one of the element is 1 and rest are 1, 2, 3, 4, 5, so the minimum will remain 1. When you take 2 and 1, so minimum is 1. And 2 and 2, minimum is 2. And then for rest of them, it will continue to be 2. Now starting with 3. 3 and 1, what is minimum? 1. With 2, it is again 2. With 3, it is 3. So 1, 2, 3 are the minimum between 3, 1, 3, 2, 3, 3. But for the rest also, for 3, 4 and 3, 5 will continue to be 3. Likewise, between 4 and 1 it is 1, then 2, then 3, 4 and 4, 4, but 4 and 5 it will be 4. With 5, of course, it is 1, 2, 3, 4, 5. So that is the operation table where the definition of star is A star B, I repeat, is minimum of A and B. So that is known as operation table. Now next sum is, let star be the binary operation on n given by A star B is LCM of A and B. Then in the first part we have to find the value of 5 star 7. What do you mean by 5 star 7? LCM of 5 and 7. And now I will not show you the actual process. This you know right from your class 4 or 5. There is nothing in common between 5 and 7, so LCM is 35. The second part is 20 star 16 means LCM of 20 and 16. You can work out, you know, the basic procedure. What is common between 20 and 16? Say 4, 4 5s are 4 4s are, and there is nothing more common. So the LCM will be 4 into 5 into 4. So that will be how much? It is 80. So the value of 20 star 16 is 80. Now the next part is, second part he asks you, is it commutative? Wait here. You see, whether you find the LCM of 5 or 7 or 7, 5, does the order matter? No. So for the third part, actually that is the second part. In the first part there were 2 subparts. The second part is asking you whether this operation star, that is LCM between A and B, is commutative or not. So I say yes, it is commutative, because when we are, you should write in words, because when we are finding the LCM of 2 numbers A and B, 2 or more, their order does not matter. So yes, it is commutative, or A star B is same as B star A. LCM of 5 and 7 is same as that of 7 and 5. Now the third part, he is asking you whether this operation star, which is LCM of A and B, is associative or not. So yes, star is associative. Instead of going in detail, I can simply say the order of numbers. If there are any three numbers and you are finding their LCM, the order does not matter. So it is there, the star operation between three numbers is yes associative. You need not to give the details. Now the next part is identity element. And here the set, the numbers A and B are natural numbers. So obviously we have to find, does there an identity element exist? What do you mean by identity element? Say E, that A star E should be same as A. Is there any natural number whose LCM with any other natural number will keep the number same? Yes. If you take 1, consider E as 1, then what is the LCM of 5 and 1? LCM of 5 and 1 is 5. LCM of 10 and 1 is what? 10. That means the LCM of any number with 1 will remain the same. So you may conclude that yes, the identity element for the given operation exists and it is 1. Now the next part, is there any invertible element? Invertible element means the LCM of A. What do you mean by invertible element? Suppose A and B are two natural numbers and then A star B should be equal to E. We say that A is invertible provided we can find out another number B such that A star B is E. And what is, by the way, E? 1. So what is that number and another number that their LCM is 1? Obviously the LCM of 1 and 1 is 1. So 1 star 1 is 1. So the only invertible element is 1. Please note down, the only invertible element in set of natural number is 1. And what is the inverse of 1? Inverse under the operation 1, and that is 1. Because the LCM of 1 and 1 is the identity element 1. Is star defined on the set 1, 2, 3, 4, 5 defined by A star B is LCM of A and B a binary operation? Justify your answer. Now before I take this particular question, let me repeat as we discussed in the beginning of this unit, binary operation. What do you mean by binary operation on 1, 2, 3, 4, 5? Say for example I say addition. Whether addition is a binary operation on this set 1, 2, 3, 4, 5 or not? What do you say? If you have understood. No, it is not. Why? Because if you take, say, natural number 3 and 4. What is 3 plus 4? 7. 7 is of course a natural number, but is not in this set. So it is not a binary. What do you mean by binary operation? That if we apply binary operation between any two elements of that particular set, the resulting element should belong to that very set. And now look at this particular sum. LCM of A and B. So let us choose, say, 3 and 4 or 3 and 5 will be simpler. What do you mean by 3 star 5? 3 star 5 means LCM of 3 and 5. Obviously LCM of 3 and 5 is 15, but it does not belong to the given set A. Let me call this set, given set 1, 2, 3, 4, 5 as set A. So the star on A is not, hence the star, the binary operation is not, the star is not a binary operation on A. Because when we apply on any two elements, say 3 and 5 belong to A, here 3 and 5 belong to A, but 3 star 5 does not belong to A. So it further clarifies you the definition of binary operation. Now next is, a star is a binary operation on set of natural numbers such that A star B is HCF of A and B. Now here, first part we have to prove. Let me first define. A star B is defined as HCF of A and B. Now in the first part he is asking you whether it is commutative or not. I say yes, it is, the binary operation is commutative. How do you justify? That HCF of A and B is same as HCF of B and A. Order does not matter. You know, HCF of say 16 and 20, HCF of 16 and 20 you know is 4. So instead of 16 and 20, even if I say 20 and 16, it will remain 4. So HCF of A and B is same as HCF of B and A, or is same as B star A, and hence the given operation is commutative. Now what is the next part? Yes, it is associative, because when we are finding the HCF of 3 numbers, the order does not matter. Let me take a simple example. Say I choose numbers 2 and 6 and 8. Okay. So A star B star C we have to prove is same as A star B star C. For the present example, it is 2 star 6 star 8 LHS. So what is the HCF of 2 and 6? 2. And then what is the HCF of 2 and 8? 2 and 8, it remains 2. And on the right hand side, it will be 2 star 6 star 8. What is the HCF of 6 and 8? 2. And now what is the HCF of 2 and 2? 2 only. So from either way we get 2. So we can confirm that yes, we can conclude that the given operation star, the HCF of two numbers, is associative. We could directly say, but in any case I have proved with the help of an example. Now the third part is identity element. Does identity element in set of natural number exist for the given operation star? What is star? HCF between two numbers. That is A star B is the HCF of A and B. By the way, what do you mean by identity element? Suppose E is a natural number identity element. By identity element, if I choose any say natural number A, then A star E should be same as A. Take an example. Suppose I take 5. So what is 5 star E should be equal to 5. Do you have any natural number whose HCF with 5 will remain 5? Yes, I have. That 10. 10 is a number. Suppose I take 10. That HCF of 5 with 10 will remain 5. But it should be unique. If I take any other number, suppose I take number 6, then what is 6 star and E we say could be 10. What is E star 10? What is the HCF of 6 and 10? It is 2. So it is not 6. So that means the identity element for the given operation HCF does not exist. Please conclude that the identity element does not exist for the given operation HCF.